Okay, thank you everybody. So my colleague is Marios, I'm Miguel. I would like to probably ask you some questions before we start so we can adapt our speech. So how many of you got some experience with Kubernetes? Hands up. Okay, right? That's nice. Okay, how many of you are pen testers? Okay, a couple of you. Okay, that's nice. That's nice. So yeah, kind of this talk is going to be about all both things, right? One is going to be pen testing, and it's going to be about security also in Kubernetes services. So so as I said, so my name is Miguel. Just to tell you something about myself. So we both, Marius and myself, work at Kevin. We are both senior security engineers, and well, me particularly, I've worked for companies like IBM, Software Syria as a consultant. Also now I'm working for a fintech, Lithuanian fintech, which is called Kevin. There you go, my references. Please do not hesitate to reach out to me. And I'm leaving you with Marius to present himself.
Yeah, I'm Marius. I'm OSCP, OSCE certified. I have about 9 years of experience in cybersecurity. And what I enjoy doing mostly is breaking stuff, offensive security, pen testing, red teaming, and that's about me. So we're going to start with the objectives and the problem statement. We're going to move to shared responsibility model. We're going to talk about the deployment models and evolution of Kubernetes, cloud and container attack vectors, and we have a nice demo of zero hero attack. We're going to talk about persistency, backdooring, using static pods. Of course, we are going to address some mitigations and controls that we can put in place, and we're going to move to conclusions. So our goal is for all of you to think like attackers and understand how cyber criminals are weaponizing most common attacks on Kubernetes, and what can we do to protect ourselves. I'm going to hand over to Miguel for the next slide.
Okay, thank you. There is something very important when you are trying to move to the cloud, right? And it's to understand which are responsibilities, right? Every time you start a new job, the eternal question, so basically, which are my responsibilities here? And when you move to the cloud any payload, it's very important to understand what is your piece of the cake, right? So I'm going to use as an example AWS, but it could be any other cloud provider. It doesn't matter, Azure, GCP, Oracle, whatever, right? We are going to basically have exactly the same problem, right? And it's understand really what is our responsibility. So the cloud provider is going to be responsible of the security of the cloud, right? And we are going to be responsible of the security in the cloud, right? So easy, right? Easy? Yeah? Okay. So it's easy, right? So you go to AWS documentation and you just get it, right? Out of the box. They are taking care of regions, availability zones, edge locations, hardware, AWS software. All of this is easy, right? Compute, storage, software, which is on top of them. And then you are just responsible of the client-side data, the operating system, network, all these things which are in there, right? Platform applications, cloud data. So we are responsible of the security in the cloud, right? Okay, so yeah, who thinks this is true? Somebody? Okay, then all of you agree it's false? So you are right, it's false. If not, why the question, right? So it's not entirely true, let's say, right? So there are different models, and when you are going to move to the cloud, you need to understand at which layer you are, which layer they are providing, and on top of that, you need to add the security, because you are going to be responsible of running something, right? And then what you are responsible to run, you are responsible to secure. Easy. So infrastructure as a service or infrastructure services are those which are providing you, as I said, infrastructure as a service, which is basically the most basic thing. They are giving you, for example, a machine, a virtual machine. In this case, in AWS is EC2. Normally, these are commonly known also as VPS, virtual private services. Servers, sorry. So then on top of this, AWS is telling us they are using container services, which is not another thing that the so-called platform as a service, right? So they are giving us a platform, and on top of that platform, we put our payloads and we run our applications. That's the thing. And on top of this one, there is abstracted services, right? And then in abstracted services, they are looking after the service they are giving you, also for the security, right? So this is also called software as a service, basically. So we are using a service, and this is managed services. So examples of these ones, I already mentioned for infrastructure as a service EC2, for those which are kind of more familiar with the cloud, AWS Fargate as an example of container services, which is actually platform as a service, and then S3 or KMS or DynamoDB, which could be also examples for the software as a service, if you are kind of in the AWS world. So what is happening here? So we saw the second one, right, which is this one, and it was kind of presented in the earlier slide. But if we go to infrastructure as a service, we got more responsibility on securing everything. You got more layers on your responsibility, and you need to look after all of them, right? So if you are going to this one, which is software as a service, you got a managed service. So that means you are paying someone to get to deliver that service for you, and they are also responsible for securing the service. So we are getting layers. We are going layers up, basically, in giving responsibility to the cloud provider and taking it from us. But the question is also, as you go to the right in this side, right, they are less adaptable, and you also got less responsibility. So the eternal question is about in which model you have to deploy your workload, and that is the first question to solve when you are going to go to the cloud. So, yeah, what this talk is going to go about? So this talk is gonna go about we are going to use platform as a service, right? Which is those container services in there. So just a quick recap on how everything has gone through the years, and something which is nowhere, again, which is easily deducted, but it's nowhere. So when you go to a cloud provider, how is the cloud provider actually getting everything out, virtual machines, container engines, anything? How is everything set it up? And the thing is, we went through the years through this sort of line, right? So we had the traditional deployment where we had our applications on top of the hardware and the operating system. Then we realized, hey, what's up? My CPU is idle most of the time. My memory is not consumed. So why don't we put more systems on top of them? So we virtualized everything. So now we got a VM engine on top of the operating system, which is running our VMs, right? And then, okay, so but is it really necessary to virtualize all of this? Or we can just virtualize a small chunk of it, right? Which would be the containers, right? And then we came up with the idea of running everything on the same kernel and isolate them somehow. So, okay, so then cloud service provider, what is it and what is doing? It's basically putting virtualization on top of virtualization. It's just building or having an operating system or a VM engine, hypervisor, or anything similar to this one, VMware, whatever. And then on top of this one, they are spawning these virtual machines, and on top of them, they are spawning the operating system in the virtual machine and the container engine. So that's how it works. And then we will have containers running on top. So for those which are not familiar to this thing, right? How containers, or what is a container? Well, a container is just, let's say, a single version of an operating system containing it, which is very lightweight, and it's able to basically run our applications in isolation over the same kernel. That would be a container. It's basically the instance running of an image. So, yeah, so then we are going to check Kubernetes. And what is Kubernetes? Well, Kubernetes is not other thing than just an orchestrator of containers. So, because it would be really nice, and one of the cool things of being in the cloud is that you got these nice technologies. It doesn't mean you cannot have it at home, right? But having it in a cloud provider, it's kind of much more reliable. So, the thing is, okay, what happens if one of those containers, which is actually running a replica of my application, it's dead for some reason, basically. So it gets killed, the application is not responding or whatever. So what Kubernetes is doing is basically monitorizing them. So if I'm running, let's say, an application for anything, let's say a buying or a shop application, right? I got different copies, I got some sort of balancing between them, and if those copies, one of those copies is not responding, the Kubernetes service will know and will respond another one, right? So, which is so cool. You don't have to be on top of things. So, a little bit of Kubernetes and how it works. So, Kubernetes is adding basically an abstract layer on top of this, and it's adding a control plane, which is going to be communicating all the time and all the way with the Kubernetes nodes. And this is how it works. So, we will have a node, which is not other thing than an instance of a VM, as we've seen in the previous slides. Just a VM, which is going to be running our kubelet and our Kubernetes proxy. And these ones are the ones which are going to communicate with the control plane. So you can have more than one node, and as you can see here, what you are going to have also are you can have more than one container running on the same node, right? So, yeah. Those are the basics. Everything is basically communicating between the kubelet and the kube API. And then we are getting into the rock part of this. So we are going to be hacking a Kubernetes cluster, basically. Of course, this is kind of a scenario that we crafted in order to show you how weak it could be and how bad things can be if you just use defaults. So this is what we are going to do. If you blink, you'll miss it. There is 11 minutes of hacking. So we are going to actually we're going to use a remote command execution that you all will know for sure because it's in a pretty well-known application. We are going to use that one to get an unprivileged shell within a container, which is running that application. Then we are privileged escalate with the container. We are going to get a root shell within the container. Then we are going to get a fully fledged shell by using a tool within the container, which is helping us to get TTY and all these things. Why do we do this? Because, you know, guys, we are cool, so we need to have a full-fledged shell. If you arrive to a box and you don't get a full-fledged shell, you are nobody, right? So, yeah. So then, yeah, we got the root shell like with limited capabilities. This is not actually that way. What we are going to do is take advantage of a flow which was there when the container was deployed, and then we are going to be able to read the entire host file system. Remember, guys, there are layers here. So what is happening is we are putting on top of the operating system a container engine. And what happens if it's misconfigured, the container can access somehow the host. Bad thing, right? So yeah, that's cool, but it's even cooler that when you got that, then you can access to the other containers. Magic. So if you are running a weak container along with the most secure one in the world, yes, you are fucked up. Yes. So then, okay, we will get the root shell in the container too. And then, of course, we want to escape here. Come on. Like, taking ownership of a container is nothing. Everybody can do it. So let's jump to the host, and then we will compromise the entire node, right? And then I will hand over to Marius, which will show you a cool thing. So, yeah, all of these, 11 minutes. So, let's go. If you blink, you'll miss it. Okay, countdown from 5, 4, 3, 2, 1, one more, 0. Come on, come on. Okay, so, so we are going to use a damn vulnerable web application known by everybody just to get into the container, right? We'll have 2 listeners at the beginning. One is in port 443 and one in port 8080. And we are going to just use this cool exploit which is there, and you think, oh, this is nowhere already. No, it is. It is there. It's still sometimes. And then when somebody is actually inputting and chaining a command to a ping command, but in the bash shell, it's actually going to run it afterwards, that command. And then what is going to happen is I'm going to send back to my IP a reverse shell, right? So when I click submit, not only the ping is running, it's running also the next command, right? Everything in a row. So no input validation, you are fucked up. So yeah, then we got a shell there, right? So we got an unprivileged shell. Why do we know it's unprivileged shell? Well, obvious. It's double B data, and yeah, we got that unprivileged shell. I didn't want you to miss. So yeah, and then now we are checking. Okay, what is there? It's kind of okay. I got ID, who I am, basically, and then I see double B data. We get uname -a to understand where we are. We see this is an actual container. Sorry for the small letters. Sorry very much. And then yeah, then we are gonna basically find a way to escalate, right? Next steps, ABC of hacking, right? So we go there, and then we find a way to escalate. So oh, sorry, I missed one step. So we are cool, as I told you, we are cool. So we need to get a full-fledged shell. This one didn't have TTY, so for those which are pen testers, if you don't know this trick, take note. You can use a script and then upgrade your shell. Good one. So then we started looking for something to actually escalate within the container, which is, come on, I need somehow to get my stuff there. So I got all my cool stuff in a zip. I want to get it there. I want to unzip it, or I just want to get my files there because I need to privilege escalate. I want to check the whole container, right? And then I start looking for something to move my files, right? Which is NC, get, curl, Python, nothing in the container. So what are we gonna do? So we can of course try to copy and paste using base64, the shared Clifford, all these tricks, right? But actually, in this scenario, what I wanted to show you is also the importance that we are crafting secure images and we harden them. And we are not leaving anything aside, right? Anything is even administrative tooling or things which could be lost somewhere. And actually, if we find for the SUID, and we are trying to search for those executables, which indeed, if you run them, they won't run under your user, but under the user who actually is the owner of the file. Right? That's what the SUID is doing. So then we find that file, we cut the content of the file, and this is basically an administrative tool which is doing is basically locating all the TMP files and executing an action. So much easier and convenient for the administrator, right? To delete all the TMP files, to do something with them, or whatever. So what are we going to do? What we are going to do is basically guarantee there is a TMP file in the folder. So we are going to create a TMP file, right? Because if it's not locating nothing, it's not going to run anything. It's executing the action on the TMP files, remember. So then, that's the thing. So we are basically creating a TMP file in there, if I'm not wrong. And then what we are going to do is change that action to bash -i-p, right? -p, really important. Because if not, it's not running as privileged, right? This is a protection they added to bash shell some time ago. So if you don't use the -p, you got nothing. And then we got our root shell with limited functionality within the container, which is cool. It's cool, but we can be much more cool than this. So yeah. So what's next? So we just escalated, got a bash shell in the container, right? Second. Okay. Again, this shell is not having the full functionality, right? I don't have the tab, I don't have a code completion, I don't have the TTY. So we are looking for socket. right? Which is another tool, very handy one. And then what we are going to do is basically send us back another shell, because I love shells, right? I love to interact with something which doesn't belong to me. So, yeah. So then that's it. So I run ps minus aux, and then what we find is the process space, right? Is the process space within the container. Why do we know this? I could ask, but I don't have time for you to give me an answer. But the answer is basically the process space, PID1 is not init. Init is always PID1 in Linux systems. So that means we are not in the host. We got a bash shell within the container. But after running socket, I'm receiving another shell, which this time is full-fledged shell. This time I got TTY, I got auto completion, all these things that I love. So yeah, so then what's next? So next is check, we are root on the container now, but we are still somehow restricted, right? We are within the container, we want to compromise the entire node. So yeah, what's a way to do that? So there was a misconfiguration in this container. And how can we know about it? So what we are going to do is basically to look for something which is mounted. Anything which is an external file system, it could be NFS, it could be NFS, it could be something else. But in this case, when we check, we see /dev/sda1 is mounted, right? So what we are going to do is just change the root directory, right, with chroot to a /host, which is the mounting point of the file system. What we are doing with this, all our commands now are checking everything which is in the Linux file system. And that means also the file descriptor for the processes. So we can now see all the fucking processes of the host, which is cool. Not yet that cool, but it's cool. So, okay, let's move on then. So we get then all the process space. As you can see, actually you see there is init on it in the PID one. So basically we are fine. We got access to the whole process table now. And then we are gonna cut EDC shadow. Why not? Maybe there are passwords, something interesting. So, but basically we are getting root and we are getting file permissions, full file permissions on the file system of the host. So somehow we managed to escape. And get the host kind of compromised, right? But we don't have still a full-fledged shell in the host. So why not try it, right? So yeah. So you may think, come on, Miguel, all the cloud providers are using Docker. You know. No, they are not. Because Docker is just a layer on top of containerd and they don't use it. They use containerd instead, right? Which was there kind of long time ago. So yeah, we are going to use CTR to interact with Docker. There is no kind of a Docker CLI, but kindly somebody left in the host the CTR tool for us to interact directly with the thing, right? With the containerd service. And then we are going to look for containers which are running within the same host, right? We can do this because we have access to the file system of the host, all the processes, and then this is basically showing us all the information that we got. The Kubernetes node is actually running, right? So, okay, we see there is an Ubuntu one, right? So why don't get into the container? That's the cool thing. So let's go there, let's pick what is in the container, let's exfiltrate data. Nice presentation, by the way, here, first line. Let's exfiltrate data from there if we want, or yeah, let's see how many things we can do with the container and check if even there could be another vulnerability in that container which is helping me to fully escape to the VM, right? So yeah, let's run that. We are going to run bash on the container, and bam, we are there. We got a shell in the container too. So we managed to escape somehow, not full escape, but we will, from the container to the host to get the information that we needed to actually reconnect to the second container. So if you got a weak container, you got basically your entire cluster can be compromised. So yeah, we are there now in the second in the second container, as you can see here. And now we are gonna try to escape directly from here to the host. What do we need to escape directly? Well, there could be different ways probably to do this. The most useful one is when host PID is shared. Again, this is a really bad practice, and it's allowing the container to access the whole process space of the host. So, yeah, why not use it? And then you got ncenter, which is handy really to run commands again as the user, which actually is holding the process, right? So we run it under PID1, which is init, which is actually a root one, and we managed to escape to the operating system with full-fledged bash. If you see in there, this is no longer the container, but the actual VM, the Kubernetes node, right? So that was cool, wasn't it? Come on. Okay, so that's it, right? So we managed to get it, and we found it. So yeah. So now a question, guys. So which would be next step here? When you perform a pen test, you land in a box, you got owned, a Kubernetes node, virtual machine, ABC of pen testing. Somebody? What? Mining. Persistence, yeah? Persistence, lateral movement. So persistence and lateral movement are the most obvious things, right? If you start mining, probably we will find somebody could find it out by monitoring the system, but definitely is a good option. Yep. Here. Exactly. That's the thing, lateral movement, right? That would be an option. So I'm gonna, and actually somebody there pointed persistence. That's what we are gonna do. So we don't want this to basically be switched off. It's gonna be gone at some point. Yes, the Kubernetes node is gonna be resetted at some point, but we need to manage to get into as many nodes as we can and persist within them, so we can use them for mining, right? Okay, so and I'm leaving you now with Marius, which is gonna drive you for the rest of the presentation.
Okay, now we are going to talk about how we can backdoor a Kubernetes compromised node. So here's the question, why would we do something like that? Red teaming. And usually sometimes we want to stay stealthy, don't mess too much with the host so we can have an easy cleanup for the SOC. And we can do that very easily with static pods. For those who don't know what a static pod is, in a nutshell, we can say that in an ideal world, you should have all the pods managed by the control plane. A Kubernetes world, we have an exception, and these are static nodes that they are managed by the node. What can go wrong there? So what we're going to do, we're going to implant a malicious pod to the manifest location of the compromised node, and the node by itself, without doing anything, is going to spin up the pod, and we are going to configure our listeners, set up our infrastructure, our command and communication servers, and we're going to get a reverse shell. We're going to use kubesploit for that. For those who hasn't played or get their hands with it, just give it a try. It's really good. It's based on Merlin C command and communication, and it has some really good post-exploitation modules for escaping compromised Docker environments. Let's see the other way of backdooring Kubernetes nodes using static pods. So there is a really nice functionality that we can exploit where we can infect the kubelet configuration by just adding a parameter that points to a remote location of manifest files. And what's going to do the kubelet engine, what we can see here, is going to request a pod to be fetched from the attacker control location. And let's start with a demo. Okay, we can see here This is the attacker node. And on the attacker, we are going to install Go. And I'm going through some steps of installation of Kubesploit. It's really easy. We just download from GitHub repository. We just compile the project. On this side, we will see the compromise node that will run the commands while we're going through the compilation process. And here, down there, we have the control plane that we could see the backdoor pods. So we run the installation steps. We have to configure to the config of Kubesploit the attacker IP. We're going to move next on setting up a public web server that we're going to use that for serving the malicious files from the attacker node to the compromised node. And we can just use it with inline Python. The letters here, they're really small, so it's really hard to see, but all we are doing is just setting up the infrastructure, downloading and compiling the server. Then we are going to move to creating the malicious pod that we can see here. I'll try to pause that. And I can talk over it. So all we do here, we have a pod in kube namespace, and we're running and download and run command on the agent that we just compile of Kubesploit, pointing to our server. So it's all we do is download the binary, make it executable, and we run it. And that's what this pod does. And also, we make it, if I can see that from here, privileged. We share the host speed with the host. And as well, we allow to share the host directory, so we can easily escape if we want to. And probably want to when we backdoor servers. And all we have to do now is we start the server for sharing the files. We got the listener of the Python server running in the background. We're going to start the servers. And we're going to start as well Kubesploit server. And our listeners are ready now. So we can see here our listeners are ready. Now we move to the compromised node. And we have to navigate to /etc Kubernetes /manifests. And that's where all the manifests and the static pods are being stored. And all we have to do is we just download the malicious pod from the attacker server that we can see here. And by itself, by just downloading, 0 steps required, we will see in the control plane that our pod is running. As well, we got a reverse shell. And we have to give it some time. We can see in the beginning is the status delayed. It takes about 3 to 5 seconds. We can see that running. And if we check again, now the status is active. So we can start interacting with the reverse shell. And of course, we're going to interact just for demonstration purpose only. We're going to run an info command. It shows some basic information about the system. And we can move to the next stage of trying to delete from the control plane the pod. And by deleting that, we can see that it's deleted. And when we run again the same command to see the pod, we will see that it's in pending status, which means that it already started again by the node. So from the control plane that we manage the pods, we cannot delete it. And we can see that here that from pending it moved to running. And now we're going to see the second way of backdooring the node. So we're going to do the cleanup. All we have to do to stop the malicious pod running is we have to delete the file that we placed in the manifest location. And now the pod has stopped. Now we are looking for the kubelet configuration file in the Kubernetes node. And to do that, an easy and fast way is to execute ps and grep for kubelet. And we can find the kube config in that location there. We copy that file, and we edit that with our favorite editor like Vim. And we have here a parameter which stores the location of the manifest files. Also, a really nice functionality of Kubernetes that for attackers is very useful. We can use the parameter called static pod URL, and as we can see, we can point to our attacker server, and by doing that, Kubelet is going to fetch pods from a remote location. And for this attack to work, we have to restart as well the kubelet service or reload the config, and now we can see that we got a second reversal there. And usually it requires a few seconds for it to get set up properly. We can see that running in the control plane. We can see the connection back. We just received the connection back. We're going to interact with it. Let's check the status of it. It's in delayed status. It needs a couple of more seconds. And now it's active. And we can start playing with the server. So that was backdooring a server with configured the infrastructure within about 8 minutes. Really nice for red teamers. Yeah. In this stage, we are going to talk about controls and mitigations for Kubernetes deployments. So, an easy way of actually preventing these things from happening is to enforce some admission control. There are a few different admission controls, some that they're already built in, which is such as pod security admission, and there are some third-party ones like Iverno, OPA Gateway, and KubeWarden. All of them pretty much they do the same thing. It's a matter of what you prefer, and some of the third-party ones, they are more customizable. They might have a better user interface. They might integrate better with your setup on the pipelines. We can configure different measures of privilege, baseline, restricted. But the biggest picture here is that we can start adding controls, like we can prevent users, developers, DevOps from running privileged pods. We can do that on the admission controller. And by doing so, restricting our kubelet configuration, then what we can achieve is that we can stop the stages of the attack. So we can say, that, for example, if we break it down an attack into multiple stages, well, we can say privileged containers, we block them. Sharing host speed, we block them. And we can enforcing a policy of actually making exploitation really hard towards impossible. I think the most important part here is that cloud environments, they're really complex. And when we have complex systems, you see lots of things going wrong. Like sometimes you do a security review and then you come across towards a complex system configuration and you really don't know how they come up with specific type of vulnerabilities. And we see that all the time. When you're pen testing something, you always see something new, some new vulnerability, some new misconfiguration. Also, we need to consider that like we might do proper hardening, but as well, we shouldn't forget about web application security and how this can impact Kubernetes, because if we have an entry point, then we rely on secondary defenses. As well, we saw in the previous demo, Miguel exploiting lots of local binaries and performing leaving of the land attacks. So an easy way of preventing things like that is you can, let's say, remove all the binaries or move to something like distro-less images that once you compromise a pod, then you don't have any tooling to perform further post-exploitation. Something that it's very important and people don't pay attention. I really don't get how they end up with that. Admission control is not configured by default. So by default, Kubernetes is insecure. We can see different namespaces. By default, they can communicate with each other. So all of these things, it takes time, effort to configure them and test them to make sure that they work properly. We also saw that placing an insecure application in a network that can be secure actually can expose the whole network, which is a new attack surface that we didn't have in the monolithic applications. As well, privilege mode, I think, is something that by default should be disabled, and sharing host paths, host speed, I think should be explicitly enabled on pods, because attackers, they do exploit that all the time. If you just go and look around for the most common breaches on cluster applications, you will see that most of them, they do escape using these specific attacks. And also, yeah, if you compromise a node, you can also implant static pods, get persistence, put your tooling there, maybe mining, if you like that. As a takeaway, I believe we should enforce security in depth, zero trust. Distro-less images is very important for limiting all the living of the land attacks. Strong software development lifecycle is very important, because we don't have to deploy vulnerabilities. We can catch them at earlier stages during development phases. Something really important that sometimes the documentation even missed that, pay attention to the security part of the documentation. Sometimes there are security-related matters that they are not part of the security. So documentation is something that we should always keep an eye. CIS benchmark has done a really great job on having some standards and some tooling that we can run on checking control plane deployments, images, checking node deployments. As well, monitor these things, because sometimes you might get compromised, but you need to have a way of monitoring configurations to make sure that everything is configured according to the best standards. Enforcing as well network controls can stop compromising from one compromised node pivoting to another one. And as well, as we saw, unnecessary privileges on the containers. Very important to pay attention there. Actually, lots of ways that you can perform privilege escalations and escape to the host, which is like running them in privilege mode, sharing paths, sharing process space, networks, inter-process communication, sharing memory between processes. And in a nutshell, that's about it, the most common things that you should pay attention. And we have the references just in case that you want to take some screenshots. Questions?
Questions, please. Do not beat anyone. If we know, it's fine. If we don't know, we'll tell you. Okay. We did it perfect then.
Thank you very much.
Thank you, guys.